Okay, Feb March 2025, paper 4, variant 2. Question 1. Figure 1.1 shows a force extension graph for a spring. You have the force on the y-axis and the extension on the x-axis. Calculate the spring's constant. Can I find the spring's constant? Yes, K equals F over X. K equals F over X. So you need a force and you need an extension. If we take this point, for example, the force would be 1000 and the extension would be 0.02 meters. You can take this point, you can take any other point. Again, the force and the extension would be directly proportional. So K equals 1000 over 0.02, which is 50,000. Okay, 50,000 newtons per meter. This is the K of this spring. A soon states that the spring has not reached the limit of proportionality when a force of 4,500 newtons is applied to it. At 4,500 newtons, okay, has it reached the spring's the limit? No, it has not yet reached the limit. Why? Because at this point, the graph is still directly proportional. So how do I know that from the graph? Because it's still directly proportional. Okay, what do I mean by directly proportional? It's still a straight line. Okay, it's still a straight line, or you can say it's a constant slope. It is a constant slope. Springs can be compressed by forces. The spring described in figure 1.1 is compressed by force F and has an extension of negative 0.025 meters. Can I find F? Yes, I can find F. You can either use the graph or you can use the equation. Okay, so if I use the equation, if you rearrange the equation, force equals K times X. Force equals Kx. So you have the K, 50,000, and you have the X, negative 0.025, giving you a force of negative 1,250. Negative 1,250 newtons. Is this a wrong force? No, it is a correct force. Negative just means that you are compressing instead of pulling. It means that you're moving in the opposite direction. That's why in question D, he's asking whether the force is a scalar or vector quantity. It is definitely a vector quantity. Why is it a vector quantity? Because it has a magnitude and direction. It has a magnitude and direction. But the force, negative force, means that it's moving in the opposite direction. That's why we are compressing this spring. Question 2, we have two trolleys. Okay. A was moving towards the right, okay, was moving to the right with a constant velocity of 0.44. So U was 0.44 meters per second. B was stationary, so U was 0. Figure 2.1 shows them before the collision. Before the collision. State the momentum of B before the collision and explain your answer. If the velocity was 0, so the momentum is also 0. Why? Because at rest, okay, any object at rest has a momentum of 0. At rest, so the momentum P equals 0. Since the velocity, or since U equals 0, you can say whatever you want. Also, you can say that P equals mv. P equals mv. The mass cannot be 0, but the velocity can be 0, and therefore the momentum is also 0. After the collision, the two trolleys are joined together. They are joined together, meaning that when they are joined together, the velocity is the same. The velocity is the same. And travel with a constant velocity of v 0.18 meters to the right. The mass of the trolley A is 0.75 kilograms. Calculate the mass of trolley B. And this is kind of a new question because we usually have the mass of the second object, but we are required to find the velocity. Again, this question, we can solve it. It is doable. How is it doable? We'll just write down the equation. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Okay. I know that there is an exception for this rule, which can be written as, since they are both joined together, there is an exception in which we sometimes write down mv, in which m is m1 plus m2. I know. But for this question, I will just write it down as it is m1 v1 plus m2 v2. Why? Because we do not have m2. So I can't just write down a capital M, which is m1 plus m2. But I can say that m1v plus m2v. Why? Because they are the same velocity. Let's plug in the numbers. If we plug in the numbers, m1, okay, the mass of A was 0.75, 0.75. u1, the velocity of A before the collision was 0.44, okay, times 0.44, plus m2 u2 is 0. Why? Because initially it was at rest. Okay, so we can just cancel out, okay, m2 u2 equals m1v, m1v, which is 0.75, times the velocity of A after the collision, which was 0.18, plus m2, don't know, m2 times v, which is 0.18. Okay, we can do it. It's easy. 0.75 times 0.44 is 0.33, which is equal to 0.75 times 0.18 is 0.137. 137 plus m2 times 0.18. Again, just subtract minus 0.137. This would give you a value of 0.1195, okay, which is equal to m2 times 0.18. Just divide by 0.18. If you divide by 0.18, this will give you a mass of 1.08 kilograms. 1.08 kilograms. Okay. Both of them are moving on a rough surface which exerts a force F on them and brings them to a rest in 2.6 seconds. Can I find the force F? Can we find the force F? Yes, this is an impulse question. It is a simple impulse question. Ft, okay, you can say Ft equals mv minus mu. mv minus mu. But in this question, the mass, okay, this is not, we can consider it to be mass of one body, but when they are joined together, the mass of both of them will just add both masses. We'll just add both masses. You can say that the velocity, the final velocity is zero or the initial velocity is zero. Doesn't really matter in this question because I don't care about the direction of the force. So you can just say mu is zero because it will come to rest. Do you have the mass? Yes. Do I have the velocity and the time? All you need is the force. So the force would be equal to mv over t, which is the mass. If you add both masses, it's 0.5 plus 108, 1.08, 0.75 plus 1.08 times the velocity of them both, which was 0.18, divided by the time, which is 2.6. Divided by 2.6. This is going to give you a force of 0.127 newtons. 0.127 newtons. That's definitely a very small force because they had too much time to stop the masses, and very small masses. They are very small masses. And they are moving at a very slow speed. A different rough surface exerts a smaller resistive force. Resistive force on the trolleys. State how this affects the time taken to bring them to rest. If you have a smaller resistive force, what will happen to the time? Time definitely will increase. Time increases. Time increases. Why? Because less resistive force means that the total resultant force on the object, okay, there is an increase in the total resultant force on the object. So if you have a less resistive force, okay, less resistive force means that there is an increase, okay, increase in the total resultant force, okay, resultant force on the object. which means it wouldn't come to rest at a shorter time. Actually, it would take much longer time. Okay, figure 3.1 shows a mains electric heater in a small room. State the region of electromagnetic spectrum which radiates thermal energy from the heater. The region is the infrared. Okay, infrared radiation. Infrared radiation. Explain why the shiny metal surface behind the heating elements increases the thermal radiation, okay, thermal energy radiated into the room. How can you increase the thermal energy radiated into the room? Okay, it's because the shiny metals or shiny surfaces are the best reflectors. Okay, shiny surfaces are the best reflectors of best reflectors of infrared radiation. Infrared radiation. You can also say they're the worst absorbers. You can say they're the worst absorbers. Okay, and you can also say that all of the light or all of the energy that's falling on it will be reflected. Okay, it will be reflected off the surface. Okay, it won't absorb any, not any, it won't absorb that much radiation, infrared radiation. The metal outer casing is earthed. State why this is an important safety feature. Earthing any metal casing, any electrical device with a metal casing. Why is it very important to earth these surfaces? Because if if the surface becomes live, okay, you want to actually protect yourself from what? To protect from the an electric shock. To protect from an electric shock. Electric shock. If the live wire, if the live wire touches the surface, if the live wire touches the surface or the case, the metal case. Okay, let's write down case instead of surface. The metal case. The mains voltage is 230 volts. Two identical heating elements. Two identical heating elements are connected in parallel. Each heating element has a resistance of 89 ohms. Calculate the current in one heating element. The current in one heating element. Can I calculate the current in one heating element? Yes, V equals IR, so I equals V over R. The voltage is 230 volts and the resistance is 89 ohms, so the current would be 2.6 amperes. 2.6 amperes. Show that the electrical power of the heater is approximately 1200 watts. State any equation you use in your words or symbols. The electrical heater is approximately what? 1200 watts. First of all, you need to think about this question. How many heating elements do you have? You have two heating elements. You have two heating elements. Each heating element will have a current of what? Each heating element will have a current of 2.6 amperes. So the total current would be equal to 2 times 2.6, which is 5.2 amperes. This is the total current. Can I find the power? Yes, power equals VI. So the voltage, they both receive 230 volts. 230 volts times the current, which is 5.2 amperes, gives you a total power of 1196 watts, which is definitely almost equal to 1200 watts. The heater is 95% efficient at converting electrical work done to thermal energy. Calculate the thermal energy emitted by the heater in 60 seconds. Give your answer to two significant figures. Okay, that's easy. Can I find the energy emitted first? Can you find the energy emitted? Yes, the energy would be equal to the power times the time. Energy would be equal to the power times time, which is 1200. If you'd like to use 1196, it's okay. Times the time, which is 60 seconds. This gives a total energy of 72,000 joules. 72,000 joules. The efficiency equation we use for the efficiency is the useful power output or useful energy output over the total input over the total input. We need to find the output. You need to find the output. Calculate the energy emitted by the heater. You need to find the energy output. The energy input or the power is this. This is the input given to the heater. Okay, so basically the output would be equal to the efficiency times the input, which is 0.95. Since this is 95% efficient, 95% means 95 over 100, which is 0.95. 0.95 times 72,000 joules, which would give you a total of 68,400 joules as the output of this heater. A train has a maximum speed of 200 kilometers per hour. It accelerates from rest. Define acceleration. Acceleration is the rate of change of velocity. Show that the maximum speed of the train is approximately 56 meters per second. Can I convert from 200 kilometers per hour to meters per second? Yes, I can. 200 kilometers per 1 hour. Can I convert from kilometers to meters? Yes. Multiply by 1,000. 1 hour to seconds, multiply by 60, and then multiply by 60 again. This would give you a total of 200,000 divided by 3,600, which is 55.6 meters per second, very close to 56 meters per second. Calculate the time taken for the train to reach its maximum speed. It has an acceleration of 0.7 meters per second squared. Can I find the time taken for it to reach the maximum speed at rest? So u was equal to 0. We have everything. We need to find the time. So v is equal to 0.7. What's the equation? A equals v minus u over t. We can rearrange the equation to find the time. So time equals v minus u over a. V 0.7 minus 0, okay, 0.70 minus 0 over the acceleration. Sorry. This is not v, this is the acceleration. I'm sorry. Okay, the acceleration was 0.75. The velocity or the final velocity, the maximum velocity was 56 minus 0 over the acceleration, which is 0.7. 0.7. This would give you a time of around 80 seconds. 80 seconds. The train has a mass of 440,000 kilograms. Calculate the force which causes the acceleration of the train. Force equals mass times acceleration. So 440,000 times the acceleration, which is 0.7, gives you a total force of 308,000 newtons. Definitely, it would be much better to write it down. How can I write it down much better? It would be 3.08 times 10 to the power of 5 newtons. That would be much better. The train travels into a headwind. The force of the headwind opposes the motion of the train. State and explain the effect of this force on the motion of the train. What happens as you face some headwind? This could be called air resistance. What happens to the acceleration? He's asking about the force. Okay, state and explain the effect of this force on the motion. What happens to the motion? The acceleration decreases. The acceleration of the train decreases. Why? As the resultant forces increase, resistive forces, okay? Resistive forces increase. What happens to the resultant force? The resultant force decreases. Resultant forces decreases, and therefore the acceleration decreases. And therefore the acceleration decreases. A light-dependent resistor LDR has a low resistance and a high intensity and a high resistance in the dark. Sketch a graph of the LDR. Can I sketch the graph of the LDR? Yes, definitely. We have the y-axis and the x-axis. even he told you to write down the resistance on the y-axis and the light intensity or the brightness, whatever. Let's write down the light intensity since he said so. It's the same thing. The light, okay, intensity. What happens as you increase the light? What happens to the resistance? Resistance decreases. So both of them are inversely proportional. How can I draw an inversely proportional graph? An inversely proportional graph would be drawn something like this. It would not touch either the y-axis or the x-axis. It will not touch either axes. Figure 5.1 shows a part of the electrical circuit. Complete the figure with the symbol for a light-dependent resistor. Light-dependent resistor with the arrows going towards the resistor. Explain why the lamp is off. Explain why the lamp is off in the light and the lamp is on in the dark. Use your ideas about the potential difference in your answer. In the light, what happens to the resistance? In the light, what happens to the resistance? The resistance decreases. Resistance decreases. And therefore, the potential difference decreases. Therefore, the potential difference or the voltage decreases. When the voltage decreases, then the brightness of the lamp decreases. Okay, so the brightness also of the lamp decreases. Okay, in the dark, what happens in the dark? The resistance increases. The resistance increases, and therefore the potential difference also increases. Therefore, the brightness of the lamp increases. All of them increase together, and they all decrease together. Okay. Figure 6.1 shows an object O, which is 5 centimeters away from the center of a thin converging lens. Okay, so the distance from O to the lens is 5 centimeters. You can measure it using your ruler. Okay. On figure 6.1, label the principal axis with P. Principal axis. So this would be P. This is the principal axis. Figure 6.1, place a letter X at a focal point. At a focal point. What is the or where is the focal length? The focal length is 3 centimeters. So you should measure 3 centimeters, which should be around this point, okay, and or the other point on the other side. So this is X. On figure 6.1, draw two rays from O to locate the tip of the image produced by the lens. Can I find the object O? Can I find the image? Yes, I definitely can find an image. First of all, you'll draw a parallel line until it reaches the center of the lens, and then it will refract through point X, which is the focal point. This is the first line. The second line will pass through the center undeflected, unrefracted. Nothing will happen to this line, this ray. As it passes, definitely you're using your rulers, please. Okay, I don't have a ruler, or I can't use a ruler now. Okay, so this is the these are the two rays after they pass. Where is the image? The image would be at the intersection of these two lines. Image would appear somewhat like this. It would be inverted, it would be real, and it would be, for this case, larger. Okay, so I just gave up the answer for the next question. It's enlarged. Yes, it is enlarged. It is inverted, and it is real. Yeah, enlarged, inverted, and real. Describe how the new image is different from the old image. The new distance between L is less than the focal length. So the distance is now less than 3 centimeters. What will happen to the image formed? The image formed will be virtual. It will be virtual. It will also be enlarged, but it will be upright. It will be upright. I can't seem to write down upright today. Anyway, Right. So it's virtual and it is upright. It's on the same side and it is behind the object. On the same, okay, side, and it is behind the object. Okay. Hmm. Figure 7.1 is a scale drawing of the light waves approaching a narrow slit. Okay, these are the waves moving this direction. Name the wave effect produced by the narrow slit. The wave effect produced by the narrow slit would be diffraction, yes. Okay, diffraction. Using figure 7.1, determine the wavelength of the light. Give your answer to two significant figures. Okay, in this scale, this is a scale drawing. It's not an actual drawing. This is a scale drawing. So it's 1 centimeter to 4 times 10 to the power of 7 negative 7 meters. Can we measure this distance? Yes, we can measure this distance. It depends on, okay, so this question will depend on your printer. Honestly, this question will depend on your printer. If you printed out this paper on an A4 paper or on a letter paper or whatever, it might differ. Okay, it might differ slightly. Okay, for example, when I printed out this paper, it was around, when I measured it, it was around 1.2 centimeters. Again, it could differ for you, it could differ in the marking scheme. Okay, so if we have the scale of 1 centimeter to 4 times 10 to the negative 7 meters, uh, for me, it was 1.2 centimeters. I will just cross multiplication, giving me a length of 4.8 times 10 to the negative 7 meters. This is my scale. Again, you could measure it slightly different. It could be slightly different for you, which is okay. Okay. But in your actual test, you will all have the same exact reading. You'll all have the same exact reading. On figure 7.1, draw three wavefronts that have passed through the narrow slit. As these wavefronts pass through the narrow slit, you need to use your compass. Open it up onto the first wave front, and then draw a semicircle on this side. Okay, so if you draw a semicircle on this side, okay, then open up your compass to the second wave and then draw another semicircle this side, and then a third one. Okay, again, your compass, your pointy edge is fixed in the center of this, pointy edge is fixed in the center of the gap. Open it up to the third wave and then draw, okay, another semicircle. I'm sorry. Okay, it would be somewhat like this. Question B. A foghorn emits a sound with a frequency of 380 hertz. The sound is heard by a ship 2.5 kilometers away from the foghorn. The speed of sound in air is 330 meters per second. Show that the wavelength is approximately 0.9 meters. Okay, that's easy. So wavelength is equal to speed over frequency. Speed is 330 meters per second and the frequency is 380, which gives you a reading of 0.86 meters. Definitely very close to 0.9 meters. Calculate the time it takes for the sound to travel to the ship from the foghorn. Distance. Okay, you have distance, you have speed. Can you find the time? This is not an echo. This is not an echo. Why? Because you're going to only hear it once. Okay, the sound heard by the ship is 2.5 kilometers away. He didn't say that it will reflect back. He didn't say that he will hear it a second time or whatever. No, he's only going to hear it once. So calculate the time taken. Speed equals distance over time. Speed equals distance over time. So time equals distance over speed. Distance 2.5 kilometers. Definitely need to convert it to meters times 1000, which is 2,500 meters. 2,500 meters over the speed of sound, which is 330 meters per second. This gives a time of 7.6 seconds. 7.6 seconds. Okay. Figure 8.1 shows a metal rod suspended in the magnetic field produced by a pair of permanent magnets. The metal rod is connected to a cell and there is a current in the metal rod. State the direction of the force on the metal rod due to the current. Well, the direction of the force, first of all, the current is moving in this direction. Inside the metal rod, it's moving in this direction. Okay, and the magnetic field is from the north to the south. So using Fleming's left-hand rule. Okay, so Fleming's left-hand rule. The first finger, which is the index finger, it's from the north to the south, pointing to the right. And then the second finger, which is the current, it's moving into the page. So kind of flip your wrist. You'll find the force, or you'll find the thumb pointing downwards. The thumb is pointing downwards. The explanation, the magnetic field is from the north to the south. Magnetic field is from north to south. And you can say that the current is from the positive. The current is from positive to negative. It's from the positive end to the negative end. So due to Fleming's left-hand rule, this is all due to Fleming's left-hand rule. The corrections to the cell are reversed. State how this changes the effect. Oh, how this change affects the force on the metal rod. Definitely the force is reversed. The force is reversed, or you can say it will be upwards. Force is reversed, or you can say upwards. C. Two magnets and a cell are used to make a simple electric motor shown in figure 8.2. We have some parts. L, K, J, K, L, M. You have J, K, L, and M. Let's define these parts and their functionalities. What is J? J is or are the brushes. Okay. What do the brushes do? What do the brushes do? They are connected to the commutator. They are connected to the split ring commutator, which is M. Okay, to the commutator. Why? To allow the current to flow in the coil. To allow the current to flow in the coil. K. What is K? K is the coil. K is the coil itself. It carries the current in the magnetic field. Okay, it carries the current in the magnetic field, and it experiences a force due to this. Okay, it experiences a force due to the magnet or due to the current in the field, in the magnetic field. Okay, a coil experiences a force on it. L. What is L? L is this thing in the middle. What is this thing? It's called an axle. It's called an axle. What does an axle do? It can rotate between the poles of the magnet. It can rotate between the poles of the magnet. Okay, between the poles of the magnet. What about M? What about M? M is or are the split ring commutator. Is the split ring commutator. Again, we should have memorized the split ring commutator. Split ring commutator. What is the split ring commutator? It reverses the current. Reverses the current in the coil every half rotation. Every half rotation. To keep the coil moving in a continuous motion in the same direction. Okay, that's it. Moving on to question 9. Strontium 90 is a radioactive isotope. Explain what isotopes are. They are the same elements. Basically, they are the same elements, or you can say same proton number. Okay, same proton number. You can say same atomic number. Okay, but different what? But different mass number, or you can say nucleon number, or you can say different number of neutrons. Okay, different number. Complete table 9.1 for strontium 90 particles. What are the particles outside the nucleus? They are the electrons. Inside the nucleus, they are the protons. How many neutrons do we have? To find the number of neutrons, basically 90 minus 38, which is 52. And they are inside the nucleus. Nucleus. Okay, inside the nucleus. Strontium 90 is used to measure thickness of metal sheets in industry. It decays by emitting beta particles. Okay. One metal sheet is 0.75 millimeters thick, suggests why strontium 90 is a suitable radioactive source to measure the thickness of metal sheets. Why? Because beta particles can penetrate. Okay, beta can penetrate thin aluminum sheets. Thin aluminum sheets. But they cannot penetrate, okay? But they cannot, okay, penetrate through thicker sheets. Thick sheets. Basically, it will give them an indication whether the sheet is too thick or not. The half-life of strontium 90 is approximately 27 years. Figure 9.1 shows the shape of the decay curve. This is the percentage. Strontium source is replaced with a new source after 15 years. Using figure 9.1 suggests why strontium 90 source that is more than 15 years old needs to be replaced with a newer source. After 15 years, what happens to the total amount of decay? It decreases. It's less than 75%. So it's not as effective. It's not as effective. So basically, you need to say that the amount of radiation, the amount of radiation produced decreases. Therefore, it wouldn't be as effective. Wouldn't be as effective. Initially, it could pass through the 0.75 millimeter thick sheet. Finally, after 15 years, no, it might not be able to penetrate the thick sheet or the thin sheet. Okay, figure 10.1 shows the path of Earth as it orbits the Sun. X is a position for the Earth where the scientists observe the apparent motion of the Sun throughout the year. X. Okay. Determine how many days it takes for Earth to move from F to G. It's moving this direction. F to G, it's around 90 days. Why is it around 90 days? Because this is only a quarter of a cycle. This is only a quarter, okay, of a cycle, which means it's around 3 months. 3 months, quarter of a cycle. Okay. Figure 10.1 shows 4 positions. Okay, shows 4 positions. E, F, G, and H. Identify the position where it's summer at X. Where is it summer at X? If you think about it, X is the northern hemisphere. So to be at summer, you need this northern hemisphere to be facing the sun, which is at point F. What about winter? It needs to be facing away, so it's at point H. F is pointing towards the sun, summer. H is pointing away from the sun, so it is winter. The orbital speed of Earth around the Sun is approximately 3 times 10 to the power of 4 meters per second. Calculate the average radius of the Earth's orbit. Okay, so we have an equation. Speed or the orbital radius is 2 pi r over t, which is the orbital time. Can I make r the subject? Yes, you can make r the subject. So basically vt over 2 pi. So r would be equal to vt times over 2 pi. The velocity is 3 times 10 to the power of 4 meters per second. The orbital time is 365 days times 24 hours times 60 minutes times 60 seconds over 2 pi, which would give you an answer, a number roughly 150 million. Okay, 150, not million, it's 150 billion. Okay, 150 billion meters, which is 1.5 times 10 to the power of 11 meters. That's why we say it's around 150 million kilometers. 150 million kilometers. Earth is a planet in the solar system. State one other type of naturally occurring objects that is present in the solar system. Any other natural, yeah, you can say, for example, asteroids. Okay, you can say comets. Okay, you have several types of things that are orbiting the sun in our solar system. Okay.